the reason we do it is so that you understand how to start breaking up that sphere. So if I have a sphere and I want to intersect it with a square thing, either a box, a shoebox, a cube, a flat something or other. If it's a slice that's horizontal through that sphere, if it's a slice that's horizontal through that sphere, anywhere on that sphere, it's going to create a circle. Right? If I slice that sphere, it's going to be a circle. So we know by doing the cube exercise that that slice in the middle is an ellipse, right through the middle, whose major axis is horizontal and whose minor axis is vertical and centered on that sphere. So by doing the whole box thing, we know this, that we have an ellipse that creates two hemispheres. So now, if I decide to slice off the top of that sphere, somewhere above there, it's still creating a circle. I slice off the top of the sphere, it's still a circle, which means it's still an ellipse, which means that the minor axis is exactly the same as the one I just drew, but it'll just be smaller. And I can continue to do that progressively towards the top of this object and towards the bottom of the object. So,
all the ellipses are like the same value? Just
they're all, they should all be about the same degree of ellipse. Okay. So it should look like you put it on a copier and reduced it.
All right.
Right. Now, if it's a really large sphere, you could justify saying the ones at the top are thinner than the ones at the bottom, because that's what happens as we go down in eye level. But all of them are going to be in the same orientation, where they all have the same minor axis, and the major axis is horizontal. So if I'm going to take a slice out of the middle of this sphere, anywhere, doesn't matter where it is, it's going to be a portion of an elliptical shape. So if hello. So let's say that we just get rid of a chunk of this sphere. So now I've got flat surface like that, and I've got this curved surface here. So I pretty much just took a chunk out of the sphere. And what the opening looks like is an elliptical shape on the top and an elliptical shape on the bottom. So now, the same is true if I rotate it. Right? It still looks the same. So what we know is that if I were to slice it vertically, now that we've done this box thing, we know that the ellipse is going to be tilted in some way. The minor axis has to go to a vanishing point. So I'll draw an ellipse on an angle that is centered on that sphere. That one's not quite centered on the sphere that I drew. Maybe I'll just draw another ellipse, that'll be easier. Okay. So if I draw an ellipse on an angle, this minor axis is now going to a vanishing point in perspective. And that means that now slicing out this slice from the sphere. based on me drawing an ellipse on an angle, because I know that on that side of the box, that's what that ellipse would look like. So doing that exercise gives us this knowledge that, okay, now I want to have a sphere and I want some sort of a rectangular thing to come out of it towards me. So I have to think about the orientation of the box that it's in. So I can think about it, maybe even sketch it up here, say, all right, if it's inside a box like this, and I want another box to come out from there like this, so let's say that the sphere is inside the first box, and I want this block to come out on that angle. So I have to visualize that, and then I know that the intersection of the side of that box, which is a flat surface, is going to slice the sphere and create a circle, which means that it's going to be an ellipse in perspective. And the ellipse that I need to draw is similar to one that lives on that left side of the box. So I'll draw it in, minor axis, going to the vanishing point, major axis is perpendicular to that. I'll draw it centered on my sphere, which now represents a slice, creating two hemispheres. And then the block is centered on that comes out from this, which means that it will come out along the perspective line. If it's the same height, it's actually not the same height, I have it stepped down, so bring it down below that. Comes out. Right now I'm just drawing the center line of that box so that I know where it starts and where it turns into block and where it runs into my sphere. And I decide how wide it's going to be. Bring that back to the vanishing point. So this point here is where the center of the block intersects the center line on the sphere. Now this top surface on the block is a flat surface. A flat surface going into a sphere creates a circle. So the intersection between this flat surface and this sphere is going to be part of an ellipse. Not a full ellipse, but a part of an ellipse.
Does that accurately reflect this initial? Because this looks not...
The proportion on this is different from that.
Yeah, right. I see the space on the sides there. I don't see represented. Otherwise, I'm completely missing. I'm completely not getting it. I'm either super wrong or there's...
No, I think the proportion between this block and this sphere is different from the proportion here.
Where's your center line on the sphere?
Center line is right here. Center line, and then that's the center line on the block as it comes out. So somehow I think the sphere that fits inside of here is bigger than what I'm showing here. So if I were to make it bigger.
The block and the sphere right down in the middle of the center line is an ellipse or an ellipse.
Yeah. Alright, so let me make it bigger. Bigger. So now the proportion is a little bit better. Yeah?
Yeah.
Okay. So the intersection of this flat surface on the block as it intersects that sphere is going to create part of an ellipse. And so I have to draw an ellipse that's on a horizontal surface, which means that its major axis goes horizontally, its minor axis goes vertically. Minor axis is going to be centered on that sphere. Major axis is going to be somewhere above. It's a pretty full ellipse too, because this point is not halfway down on the sphere. So what I draw is an ellipse that fits into the sphere and hits this point that I already identified. So that becomes the line. If this block were full width, like a sheet of paper going through, it would wrap all the way around. But it doesn't. It ends here, and it ends here. So the only lines that we need, colored pencils today, is going to be this one. So that's the intersection of that block on that top edge. But now something else happens on this side, because we've got another flat surface intersecting the sphere, which creates a circle. The circle is now on the left-hand side of the block, which means that its minor axis goes to the vanishing point like that. So I have to draw another ellipse that goes through this point, because that's the only point we have. This is the minor axis, and it's going to go this way. So that becomes the intersection between the block and the sphere. So each of these intersections is a portion of an ellipse based on the original block, knowing that on that cube, this ellipse, minor axis, major axis, this one, minor axis, major axis, and the top one, horizontal and vertical. Because that's true, however you slice that sphere on those surfaces. So with a rectangular block, it's relatively easy. Got to figure out which direction those ellipses are going. And so then this contour line here, this center line, was the initial line that I drew, which is a portion of an ellipse. And then I continue that down the front of the block to identify that shape.
I mean, I'm a little confused because you started off by talking about the box you used, or the cube you used to construct the sphere, right? And like the purpose of that, and this didn't involve that.
Right.
Okay.
Right. So we use the box, like this whole idea of creating the sphere inside the box is to teach you guys about slicing that sphere down the middle.
Okay.
So that we're clear on which way those axes go and how those ellipses relate to that sphere.
Okay.
And so having that knowledge, you can then
Know which way to draw.
know
it
where
is.
the center line's going to be on that sphere, because you know how to draw in that ellipse. So you don't have to draw the box, you can just draw the ellipses.
So because we understand it conceptually, we never have to do that again?
Probably not, no.
That's good.
Probably not, see,
That's
because now you know how to just draw the ellipse centered. And then with that knowledge, you can slice it up however many ways you want.
When you're picking your viewpoint then from a sphere, is it the value of the ellipse that you put inside of it?
Determines yes.
the view,
Yes.
the viewpoint
So if
of
I
it?
have other things in this picture, if there's a block in this picture of something and its orientation is from a very high eye level like this,
Mhm.
this sphere and that cube are not in the same world. And so it depends on which I start with. If I start with this cube, well, then I need to adjust this ellipse and make it much, much fuller. And then the slices off of this sphere will have a much different shape to them. If we go the other way around, then I would just draw a cube at a different orientation so we're seeing less of the top so that that ellipse relates to what I'm doing on the sphere.
Okay. And then to find a center point, the center point of a sphere to like make a box to either attach anything to it.
Mhm.
You're always finding it like this method right here.
Well, the center of the sphere
Just by
is
segment.
easy. It's just the center. It's really is just the center. That's the center of the sphere in 2D, in 3D,
In
in
any
everything.
view?
Mm-hmm. In any view. That's the center of it. That's not the point it's sitting on.
Yeah.
But that's the center of it. And so if I have a block next to it where I'm seeing a lot of the top, like that, then draw an ellipse in the top of that box to see how full those ellipses need to be in the sphere. So then, to find the point that it's sitting on, I would draw an ellipse that looks like this one in the bottom of that sphere. And that gives me sort of an approximation of the point that it's sitting on. Now, if I wanted to be more accurate, I would draw, no, can't do that. You'd have to draw the whole box around it.
Really? So can you do that without drawing a box off to the side? Like finding the point that it's sitting on?
Say that again, without drawing a box.
Without like, is there, you know what I mean?
Like the box doesn't exist from the point that it's sitting on of wherever the hell you want it to be, because there's no context yet.
Well, but
I guess.
based on this viewpoint,
Yeah.
you kind of have to guess.
Okay.
You have to guess at where exactly that point is. Now I can draw a cylinder around this, which would be easier than drawing a box around it. But even still, you don't know how tall that is. Right? Yeah. So that's kind of the way that you can approximate
Okay.
it.
That's cool.
So then there was a question about a cylinder intersecting with the sphere. So if I have the sphere, and let's look at it from the side view, and I put a cylinder intersecting that sphere, the intersection ends up being a straight line in side view, which means that it's a circle, which means that in perspective, it's an ellipse.
For some reason, I just couldn't get it to look right.
It kind of look right.
And
So,
it almost made it look more like a circle. Like you put contour lines on all day long, and for some reason, it still
it's a little bit
felt
right.
like a circle.
So I'll start at the bottom actually and work my way up. So I'll draw the cylinder. And the reason I'm starting at the bottom is to determine the fullness of the ellipse, because that identifies the perspective on the drawing. Because again, we've already determined that on the sphere, it's very difficult to do. So then I'll bring up the sides of the cylinder and draw another ellipse, which will be a little tiny bit thinner than that one. And that becomes the intersection between these two objects. And it doesn't slice off a whole lot of that sphere. So it still looks very round. But that ellipse is the intersection of those two. Does that kind of answer the question?
Yeah, I think it's just the way it is, like the way it turns out, that it just plays with my, like the way I think it should look and the way it looks.
It does look.
Yeah.
Yeah, well, because especially if your cylinder is smaller than the sphere, you probably won't see that intersection. Because if this were any thinner, well, if we're thinner, then I'd see it more flat. If we're fuller, it would look less like that. Like if I'm looking down on this thing, we're seeing a lot of that handle coming up, then the intersection would be behind my viewpoint. I'd actually be up above looking down and I wouldn't see that intersection. So I'd be seeing a full circle. Does that make sense?
I just think I was like at both extremes, where like it was, you know, a large ellipse, and then it made it look like the circle was cut into this cylinder, and then I was too shallow of an ellipse, and then it just made a straight line,
Yeah,
which made it look like a circle in a box.
right. Right. Alright. So, and so then the same thing is true for the cone. If I were to put a cone coming out of the top of this, the intersection between the cone and the sphere in side view ends up being a straight line. So anytime it's a straight line, you know that you're slicing that sphere, and it's a circle.
If you would emphasize this guy instead of this guy, would that completely change what was going on, or would it be something that couldn't happen?
It's something that wouldn't happen.
Okay.
Yeah, because you'd be seeing two different
That would
perspectives.
be like the cylinder overlapping the circle.
Well, you could do, right, the cylinder would be in
Oh, right,
front.
that would be looking at the bottom of that.
You'd be
See
looking
what's-
up at it, so I would see the bottom of this, which is fine. And then the intersection between, bless you, that cone and that sphere now becomes something different.
Okay, yeah.
So it's like
This
it's
is
flying.
It's just a different thing.
Yeah.
Okay.
It's the same object, it's just looking up at it instead of looking down at it. Yeah. On this one, we're looking down. All right, so are there any other sphere intersection questions?